Hi there, this is Dr. Embody with Project 9. So what do we have this time? Well, first of all, I've got a green screen behind me. We'll see if I can figure. I've got it there for Zoom. Been playing around with that. We'll see if I can make it work for Camtasia. It's actually an old tarp that I use when I go canoe camping. It's how we throw it over, hang it in some trees for when we're cooking out in the rain, because you can't cook in your tent because you don't want fumes in there. You don't want the food smells to attract the bears. So my wife and I go backcountry canoe camping in Canada every summer. So we got to watch out for bears. But anyways, that's sort of a quick story about my green screen back there, working at home. So Project 9, speaking of working at home, we actually grabbed some data on the coronavirus. By necessity, because we fixed the data for testing, by the time you're working on it, it will already be old. I hope that I might just for fun throw in, closer to the deadline, some of the latest data. But here's what we're trying to do here is show that you can grab some real data and do some simple analysis on your own. And although we don't really look at the exponential growth here, it wouldn't be hard to, if you looked at the data that we have here, if you looked at it over time, you would be able to see, be able to observe the exponential growth in the number of cases. Of course, it's kind of variable right now because we aren't doing anywhere near as much testing as we have, so the data is not very good. Some of the best data is actually coming out of South Korea, where they, in the same time period that we tested a couple of thousand cases, they tested 250,000 people. So the data, the quality of the data has an impact on your analysis, and so. We by necessity for the course, we have to use kind of old data. So by the time you're doing this project, you're dealing with data that's a couple of weeks old, and this is moving so fast that's ancient data. But given that, let's take a look at the project, see what we're doing here. So we have a file of data that we got out of the CDC, and as we've done in many of these recent projects, we're going to open the file. This one is a little. We've put a little twist in there that it will have a default. So you just put in a carriage return, and it will grab the standard file that we have. There's also one that we use for testing, which is small. And like this says that this was. The latest version we have was from March 15th, and the small one came out of February 5th there. And then we're going to read the file, right? We're going to read it out of our file, just like we've done before. We're going to put it into a dictionary, and this dictionary has a structure which now should look somewhat familiar to you, in that we have a key, which is the country, and then we have a list. And we can see the square brackets for a list. So we're starting with a dictionary at the highest level, and for each country, China or mainland China, United States, etc. And then within a country will be what we called areas. Now, in the United States, it's mostly cities. Other places, it sort of depends on how the data was collected, and it's not standardized, and they try to standardize it to put it all in one place. Some places they're provinces, some places they're states. So we just call them generically areas. Although we started calling them states, and you'll see later on that one of our functions still has the word state in it. But for any one of these areas, we are going to have a tuple. All right. So, but what is the area? So the area itself is a dictionary, right? So we have a dictionary by country, and within the country we have a list of areas, and each area is itself a dictionary, right? Kind of a messy data structure, and we tell you, which columns this information is in, and so we have a tuple, last update, the cases, the deaths, and those that are recovered. In the functions that I'm taking a look at today, when I'm talking about this, we're actually going to be interested in this piece of data. How many confirmed cases are there? And so now, because we have a dictionary of lists of dictionaries of tuples, we have to dig deep down in order to get at those cases, and we'll take a look at that. All right, and so we build these, and so here's actually an example. If my table looks like this, then my dictionary entry looks like this. And again, out of this, we can see the structure that we have here of a dictionary, and we talk about the U.S. Okay, so there's my key, all right, and then the value. There's the beginning of the list, and there's the end of the list. Okay, and then within there, let's actually, so within there we have these areas. So we have Chicago, which has this tuple, all right, and there's the end of Chicago's, and with the comma, and then we have San Benito, California, all right, and its tuple. Okay, so we have a list of these items of Chicago, San Benito, Santa Clara, Boston, and so on. All right. And then we also have a note is sometimes the area is that is empty, and so we just, our standard thing to do is to put something there, because we do need to have a key, and it will be n/a for that. All right, so let's take a look. So there's one here called the top affected by numbers, and let's see, is that the one I wanted to look at? Yes. And so what we're doing is we are, nah, that's not the one I wanted. Let me pop by my numbers. I wanted to, oh yeah, right. It's by the total number of people. Okay, and that's right. And so for that, how many people are affected, we're going to use the cases column, right? That's that's this one here that we put together, all right. And so we're looking at how many cases are there, and so let's take a look at that at how that might look. And what I'm going to do is for the test case for that one, we have a dictionary of that data, and I've just copied it off of the test case. And in here you can see, okay, so data is it's a dictionary, and if we look at mainland China, there's a list, and that list is actually kind of long until we get to, oops, let's see, I just wanted to highlight this. Let's go here. Same thing. All right, so there's mainland China. There's the list that starts out, and it goes all the way down to here. Okay, there you can see there's another square bracket there. And each entry in there is a dictionary. All right, you can see the curly braces there. And then within each one of those, there's a key and there's a tuple. And what I wanted, so what we want to do here is within each of these, I want to add up those values. Okay, and so I want to go through, and for every area, city every area in mainland China, which of course China would prefer that it was just mentioned as China, that we in fact add up all these. Okay, so now what I have to do in order to add them up is I gotta find them, and here is what I wanted to show you was how do I go about doing that. Now you could just think about it, but you can also do it kind of experimentally, and you can copy this data right out of the test on Mir. So we know we have a dictionary, and so I'll go KV dot items, right? And I'm going, so what's so we have the country. I'm actually going to do so it stands out a little better. All right, that's my country, and then let's print the areas, and then and from that just print the V. And what do we get? Okay, we get. Well, first of all, if I wanted to use the spider's way of doing it, I can go and look at each of these, and there's what Australia's looks like, and there's a particular value in there. It's possible to drill down there, but so here is a particular country. There's Australia, right? And we can see the values in there are we have a list, right? So I've got Australia as the key, and then when I just printed the value, I got a list with 4 entries: New South Wales, Victoria, Queensland, and South Australia. All right. So now what I'd like to do is drill down a little further, and can I print those out individually? Just using the up arrow here, I can get this. And so now what I'd like to do is let's go through that list. And so if I wanted to, I could call that L, because it's you'll help me remember that that's a list. So for items in my list, let's print each item. And now we see what we get. And let's go back. And let's go back and find Australia again. So here we have Australia, and so we've got Australia there. And now we're going to print out the areas. And now I've printed out. Notice I don't have the square brackets, but there's my list. And now I've printed out each of these. And what's each of these? Each of these things that I've printed out is a dictionary. Okay. So let's go back to what we were doing here. And so really these are dictionaries. So I'm going to call them Ds. All right. That's exactly what I had before. But what might we do in each dictionary? All right. I want to, all right, so let's see. If I have a dictionary, let's print out the key value in my d.items. All right. So I will print my key, which is an area. and then I will print the value. Okay, and see. And actually, I think what I'll do to make it a little easier to read, let's put a tab in front of there. Now let's see what that looks like. Okay, so let's go back and find Australia. Boom, boom, boom. Here we go. Here's all the information about Australia. And what do we have here? So we have, we've got the country, and now we have all the areas. And so we have New South Wales, and its value is this tuple, and we are interested in this column here. So the 4432. So can I now print those out? And the answer is yes, of course. And I can print those out, and then I can find the sum of those values. And I'm going to stop this exercise right here, and with the confidence that at this point you would be able to figure out first of all how to print those values, because that's what I like to do, to sort of experimentally go and then I can figure out how to print them. And then once I can print them, then I can figure out, oh, okay, I know how to add these up. Okay, so let's take a look at another function. I wanted to do a thing. So in main, we have a bunch of choices, and after we have printed something out, then we'll be asked if you want to plot it. And on this case, we say here that we're going to plot the top 5 countries. Okay, so we have a list of results, right, which was returned from calling in the appropriate function. So I have a list, and I want to take the top 5. Well, how do you get the top 5? Well, by now you know how to do that. You sort and you slice, and so now I have a list of the top 5. And then, because I want to plot it, I need a, if I'm going to plot something, if I'm going to make a plot of things, then I'm going to have a bunch of X values and Y values. And the way the plotting works in Python is you're going to have a list of X values and a list of the Y values where these correspond to each other. So the first one in this list is the XY coordinate of a point, and then the second one in each list is the next point in there. So these have to be ordered so that they are they correspond to each other, so they plot properly. And we had that in the previous project, so there's nothing strange there. So what I want to start with this time is start with a list, and it's already been sorted and sliced so that we have the most, this list is on the areas, and what I need out of this is I need to have 2 lists. One list which has the countries, right, and the other list which has the values. Okay, so I can think of this as being, right, because these are the coordinates, right? You have an x coordinate, I'll call this x1, y1, and this is x2, y2, and I wanna print those, right? So I need a list of x's and I need a list of y's, and of course they have to be corresponding in order to be able to plot correctly. Well, this is a place where the list comprehension is nice, and I could say x values or y values, but I think I'll call them countries. And how might I do it? Well, if I'm collecting the x values and these are tuples with 2 things in it, I can simply do that. So I go through my list, right? That's this list. And each tuple that I grab has an X and a Y. Right? So we have an X value and we have a Y value. So for XY, I want to grab just the X value and I want to make a list of those. Right? So what do I have for countries? I have that. We can also look up here and see the countries. And we see US, mainland, China, Canada, Australia, and France. And then I can do the same thing to get the values. I can do a list comprehension of that. Hopefully that's pretty clear in how you could do that. Then I'll have 2 lists that I can send to the plotting function, and we give you that plotting function, right? Here it is, plot by numbers, a list of the countries, a list of the values, and so I just sort of showed you how you generate the list to make that plot. So hopefully that gives you enough to help you get started. Good luck.